Hello everyone, my name is Inusarabi Isa Bodumas. Welcome to Kadiltron's tutorial platform. Today we are going to talk on different types of stresses. So stress is one of the fundamental properties of material to determine its strength in nature. So this stress is very important in many aspects of engineering and technology. Indeed, when a structural member is under a load, predicting its ability to withstand the load depends on the internal load, cross-sectional area, and the properties of material. The quantity which, given the ratio of the internal force to the cross-sectional area, is the ability of material to withstand the load, which is known as stress. So in a nutshell, stress is force applied per unit area. That's the normal cross-sectional area to which the force is applied. For instance, if this is a cylindrical element, so for instance, supposing we have something like this, and we also have, so let's assume this is some small portion we take to do our analysis. So let this to be the force for the small infinitesimal element, and then we have the area, which is TA. So the stress is equal to the limit of the forces at the A tending to infinity to 0, that the infinity of the change in force over the change in area. So for the whole element, the stress is just equal to the force applied over the area. So this is what we call stress. So now stress is divided into different types depending on its property and the force applied. So without more ado, let us go into an action. So the first type is, let's call it A. So we have what you call normal stress. This normal stress is the stress applied normal to the material or normal to the area of the material, which result in either compression or tension on the member depending on the types of force applied. So this is what we call normal stresses, and is the force applied, that's the normal force all over the area. So that is the normal stress. So this normal stress is divided into two. Number one, we have what you call tensile stress, and then number two, we have what you call compressive stress. So let us explain the tensile stress and the compressive stress. Tensile stress happens when a load is applied on a body and the load tends to pull the material away from each other. This result tends to pull the material from each. This result in an extension of the material in the direction of the load. For instance, if here is a material in cylindrical in form, here we apply a force maybe P, and then we have another force which is P. So if you look at this object, we can see that the force is trying to fold the material far away from each other by applying the force in different direction. So this will result in the extension or the tension of the member. For instance, something like this. So in doing this, there is a reaction force which is trying to counterbalance the tension force. So this is what you call compression stresses, and the material is tending to increase in both direction. So if here is L, then we have the L, all are the L. So therefore we can see that in this case the final length, let's call it L2, is greater than the original length as a result of the tension in the member. Therefore in this case the extension is positive, that is, extension is L2 minus L1, which is positive. So under equilibrium, this force applied load is equal to the reaction. Therefore the tensile stress is equal to the force all over the area. So this is equal to the reaction all over the area. Now the second types is the compressive stress. So in this case it's often when a load applied on the body tend to push the particles of the material close to each other. This causes the shortening of the body in the direction of the applied force. The applied force is known as compressive force, and the corresponding stress is known as the compressive stress. So by implication, the corresponding force that causes tension is what we call tensile force. So let's have another instances for better understanding. Let's assume here we have a structure. So in this case the compressive force is something in this direction. Here is P. So looking at this, we'll see that the material is trying to compress. For instance, so here is a reaction which is trying to oppose the applied force. So under equilibrium condition, this force must be equal to the reaction, and the compressive stress is going to be equal to the force applied all over the area. So this is, for instance, the area, which is equal to R over area. And we know in this case the new length must be less than the original length. For instance, this might be the new one, because we have, so this is the L and here is the L. So in this case we have seen that the L1 must be greater than the L2, that's the new length, because of the shortening. Therefore, the S tension here is equal to L2 minus L1, which is negative. Now, the second type is what we call shear stress. Shear stress is when a load is applied on a body and the load causes one portion of the body to slide over adjoining portion of the other part of the body. Such force is known as shear force and the corresponding stress is known as shear stress. For instance, here is the two member of the part of the material. So here we have a force here and we have a force here. So such kind of force will try to pull the material over adjoining section or in slide manner. So this type of force is known as the shear force and the corresponding stress is known as shear stress. So in this case, the shear stress is denoted by something like this, tau, and is equal to the force applied over the area. So now this shear stresses is divided into two, namely we have single shear and double shear stress. So in single shear, this is a typical example of single shear because only one section is applied over the body. So this is what we call single shear. And the double shear is when we have a body, for instance something like this. So in this case, so if here is force is applied P, of course these two sections must divide the force maybe A and B, A to 2, something like this. So this one section will take the half of the force. Maybe if we apply law of equilibrium, we can see over 2. This will be over 2. So the shear stress of each section under double shear is equal to the force over 2 or over the area, which is equal to force over 2A. This is for the case of double shear. And we can just say this is equal to the force over the shearing area. Shearing area. And this shearing area depends on the types of shear. In general, if we have n shears, that the material undergo an n shears, not double, not single shear. the shear stress is going to be equal to the force all over N times the area. This NA is what we call shearing area. These shear stresses are found in bolt, pin, rivet, etc., which connect various structural members and machines components. So this is the shear stress. Then the last types we have is the bearing stress. So bearing stress is having, for instance, let's take an application and explain for better understanding. In bolt connection, highly irregular pressure get developed on contact surface between the bolt and the plate. The average intensity of this pressure is calculated by dividing the load by the projected area of the contact surface. This is called bearing stress. So bearing stress is a stress developed between the contact of the two surfaces when the force is applied. This is what we call the bearing stress. So for instance, if we have an element like this and so in this case, here is the diameter, this is the thickness, and this is the diameter of this surface. So the force is applied in this contact surface P, and it will cause a bearing stresses between the surfaces, the contact surface of the circular face and that of the structure. So in this case, the bearing stress is given by the force applied all over the thickness times the diameter. That is to say, we have something like this. This is the diameter, and this is the thickness. So here is the thickness and here is the diameter. So this is the area of interest. So this is what we call bearing stress. And this bearing stress might also found in the bolt, nut, and other structural members used to join two or more parts of the engineering device. This is the end of this lecture, and if you have any question, do not hesitate to forward it to us via our channel or through the contact detail we provide in the YouTube. We look forward to seeing you. Thank you very much for bearing us. See you there.